Hi, everyone. I'm Leslyn Keith. I am the president of the board for the Lipedema project, and I'm also the director of research. And I wanted to present to you today about some exciting research that actually came out in 2019, but I think it's super important for women with lipedema. So the title of this paper is a PRDM16-driven metabolic signal for adipocytes regulates precursor cell fat. Okay, super complicated title. And also the article itself is pretty technical, but don't let that alarm you. There's some pretty cool stuff in this that I want to lay out for you today. And also, you can get this in written form. I also have a blog post that came out about this article on our Lipedema Simplified blog, and that's at lipedema-simplified.org/blog. It just came out today, so the same material, I'm presenting it there. So if you do better with reading it, that might help. But let me go through this article with you first by defining a couple terms, because just in the title itself, there's some things that you may not know that I didn't know until I read this. So first, what they're looking at is this PRDM16 molecule. And so this is actually a regulatory protein that among other functions, it seems to influence the formation of white, brown, and beige fat, which I'm going to also define for you. And when you have higher levels of this certain regulatory protein, it seems to influence the formation of brown and beige fat, which we really want. The darker the color of fat, it means it is more metabolically active. Hi, Gail, I see you just came on. So then let's look at those types of fat. So white fat, that's the least metabolically active. This fat is predominantly just used for storage. And sometimes it's really hard to access that fat that's in white fat. And we're wondering if maybe lipedema fat is mostly white fat. And then brown fat, this is the most metabolically active. It has a lot of mitochondria in its cells, and it can create heat. And this type of fat we use this very easily for energy. And then beige fat is really a combination of the two. It has storage properties, but it also has this burning for energy property. So then another thing they talk about in this article is beta-hydroxybutyrate, or BHB. And this is a ketone, and it's quite often used in the human body for energy. So the liver produces ketones from our fat stores, and also it is from the fat that's we consume. So this really interesting article is showing that possibly that fat cells can use BHB, or that ketone, to act on other cells to stop fibrosis formation. And fat cells that express a higher level of this particular regulating protein, PRDM16, they secrete more BHB, or that beta-hydroxybutyrate, that ketone. Unfortunately, levels of BHB and PRDM16, that regulatory protein, decrease with age. So what they wanted to do with this study is they wanted to determine if you increased the activity of this particular regulatory protein, if it would decrease the formation of fibrosis in fat, and then hopefully also transform the fat from white fat to beige fat. So because increased levels of this protein increase the expression of ketones of that BHB and which is known to interfere with fat formation, we were thinking, the researchers were hypothesizing that a ketogenic diet, which generates BHB, would result in less fibrosis and transform the fat into more metabolically active beige fat. So super important stuff. I think it has a lot of implications for women with lipedema, because we're thinking that we have the women with lipedema have less metabolically active fat, also have fibrosis in their fat, both of which could impede fat loss, particularly particularly the lipedema fat. And so this could have another implication for why ketogenic diets may be really good for women with lipedema. So again, this is going to be, it's also in the blog that was posted today, lipedema-simplified.org/blog. Check that out if you want to read more on this. And it also has a link to the actual article if you want to check that out. So let's look at the actual methods of the study. So one thing I got to talk to you about first is this was an animal study, not the best thing to prove what's happening in humans, and then also extrapolate it to possibly women with lipedema. But it's an excellent starting point. This is such an interesting article, an interesting study that I think it's good for us to look at, and then hopefully maybe some of this can be tested in humans and specifically women with lipedema, which would be awesome. So in this study, they had mice. They fed them a liquid diet, and it was either a standard mouse chow diet or it was a ketogenic diet. And they did this for 30 days. And both diets had the same caloric level. So they were identical in that effect. And then also, because it's known that exposure to cold can help change white fat to beige fat, then for 4 days, the animals were exposed to cold to see if that encouraged that transformation to beige fat. And then, so after the 30 days, they were, the fat at the groin of each animal was analyzed and tested. And then they, in a petri dish, they exposed those fat cells to ketones or BHB, and also to this regulatory protein, PRDM16. So a little bit of a complicated little methods there, but the results they got were very, very interesting. So mice on a ketogenic diet in the study showed decreased fibrosis in their fat tissue compared to the mice on a standard diet. That is very, very promising. And then ketogenically fed mice had an increase in beige fat formation when exposed to cold. So the mice that had a standard diet did have some beige fat transformation, because that's what happens when you're exposed to cold. But even more fat was transformed to beige fat when they were fed a ketogenic diet. So also an important implication of this study. So interestingly, the authors, through other little testing and stuff they did, they found that aging can impede the formation of beige fat. So even if you have a ketogenic diet, they hypothesize that as you age, you may not form beige fat as well. And then the PRDM16, that regulatory protein, can actually protect against the formation of fibrosis that forms as we age. So that's cool. And then also this PRDM16 protein actually causes the production of more ketones, which is really awesome. And BHB, that ketone all by itself, can inhibit fibrosis and promote the formation of beige fat. All really good stuff for women with lipedema. So my takeaways from this study is that many women with lipedema, particularly at the later stages, they tend to have very firm and fibrotic fat. So I think that this speaks to why anecdotally we've been seeing that when they use a ketogenic diet, the tissue seems to soften. That the fat nodules seem to get smaller, and we really didn't know the mechanism for it. And this could possibly be one of the mechanisms for it. And then my own hypothesis is lipedema fat may be made up predominantly with white fat, which is the storage type of fat that is not going to transform really easily into a metabolically active fat that can be burned for energy. And so using a ketogenic diet this may be another reason why keto can really help us to access that lipedema fat. That's one of the discussions that we've been having in a lot of our social media groups and other support groups. We're talking about, okay, so keto is going to work for regular fat, but does it really access that lipedema fat? Maybe we're not getting that part, but this study, albeit on animals, is very promising that we might actually be accessing the lipedema fat as well, as we're transforming it into more metabolically active beige fat and then helping to burn it off. And I think I already talked about too that the fibrosis in fat can actually hold on that fat and make it more difficult for you to lose. And so it becomes very, very important for us to be able to reduce the fibrosis in our fat. And it seems by this study and several others, they're showing that keto can reduce fibrosis, particularly in fat tissue. Really cool stuff. And I also wanted to point out too that we're having our virtual symposium on April 29 to May 1st, the Ketogenic Revolution for Lipedema and Lymphedema. And one of our speakers and a co-director of the symposium, Siobhan Huggins, is going to be talking specifically about this topic, about lipedema fat and the fat that we get in lymphedema and the fibrosis and what it is and what we can do about it. So she'll be talking about this even more. She's an exciting young researcher that has even a more clearer understanding of fibrosis than I do. So I really encourage you to look at our information about our symposium and register for it. And hear Siobhan's talk as well as all the other incredible talks that are going to be at the symposium. I think this was an incredible study. Again, it came out in 2019 by Wang and all it was done at the University of Pennsylvania in Philadelphia. And I just reread it again and just was thinking, I didn't even get the implications the first time I read it. And sometimes you need to read these studies and these articles more than once to really understand it. So please go to our blog post. Again, if you want to get an actual copy of the article, there is a link to the article in the blog post. And I look forward to, if you have any questions, I'm looking at just some things that people are posting from Facebook and from YouTube. And Elaine is asking about any negative side effects. And I'm not sure what you're thinking about, just negative side effects to eating keto in general, or in particular for this study. Elaine, let me know on that. They did not report any adverse effects, but again, this was on mice, and we tend to do the adverse events for animals are a little bit harder to quantify than on humans. So in the study, as Elaine says, and so I did not see any in the paper talking about adverse effects. Of course, we have over 100 years of data of humans using a ketogenic diet with various conditions, people who are healthy, athletes, as well as people who have various health conditions. And now there's actually quite a few papers and small studies that are coming out with women with lipedema specifically. So, but what we don't know is a clear mechanism for why it seems to work, why it seems to reduce pain, why it reduces fibrosis, as we're seeing in this article, why it can transform us into metabolically active fat, so that that lipedema fat might be able to be accessed and burned for energy. That's what we're still trying to discover, is what are those mechanisms. But as far as people using this way of eating and improving their condition, improving their quality of life, everything seems to be pointing in that direction, and not so much in adverse events from the diet. So That's all I have for you today. I'm really excited about this paper and other papers that I'm going to be bringing to you on the first and third Thursday of the month when I talk to you about the research update with research that really has implications for women with lipedema. So I look forward to being with you again. Thank you so much for joining.